Hi, it's B. Cameron Gain, correspondent with the New Stack at KubeCon plus Cloud Native Con in Barcelona. I'm here with Ashish Kutiala, Director of Product for GitLab. Hi, thanks for joining us.
Thank you very much for having me here.
And today we're talking about the software, or about software development platforms and the repository component built around Git, and how they must really boost the range of what they offer beyond just serving as software repositories. I was wondering, in a nutshell, why is that the case?
So, we have seen the adoption of Git really take off. It offers some, well-known advantages over, your traditional repositories, the distributed mechanism of it, the speed of it, the ability to share code, inner sourcing, etc. But if you look at, the complete software development lifecycle, so storing code somewhere, but then taking it, making it usable to the end, or consumable by the end user, you still have the traditional software process, that you need to go through, or software development lifecycle. And that hasn't changed for a very long time. You have different specialized teams working on different components of this lifecycle. So somebody takes code, writes it, uses the repository. Somebody else writes test cases for this. Somebody runs the test, and then it's given to the next team for security checking, performance testing, and then it's given finally to the operations teams, or security team before the operations teams. So there's still a lot of manual handoff from one team to the other. It's almost like throwing this over the wall, and this is changing. It isn't really that acceptable anymore in the world where the world wants to go faster. The customers want to use software as a differentiating mechanism with their competitors. You need to respond really fast, and these manual hands-off are full error prone, and they take time. And so more as we pivot towards agile and DevOps, people who are using different teams and different tools and stitching them together are finding it really challenging. Not only is it slow, time-consuming, error-prone, but it's really, really very costly. And so, whether it's Git or not, but especially the Git-based repository vendors are starting to look at, at GitLab, we only used to offer a repository based on Git. But then we used to take the product and integrate it into the pipeline, do continuous integration. And very early on, our founders kind of realized that there were two separate functions, and it took from one function to the other function to jump, and so they decided to kind of bring it together into a single application. So as soon as you committed, your code into Git, it would take it and would start building it, integrating it into the main trunk, and the users found this experience to be immensely valuable, and really accelerated and made their user experience really good. So that led to the realization there's so many stages in the software development cycle, you should really not have to stitch together many different tools. And so we are kind of we have built the single tool for the entire application development process, specifically focused on DevOps. And we find that more and more vendors are starting to do that. They're either buying companies and integrating them, or they're starting to build this in-house. And so we believe the path forward is, you don't need multiple tools. You start with Git, and as soon as you check in your code, everything should happen automatically. So that's the value that everybody has to offer to speed up the lifecycle, make the experience much more pleasant and frictionless for the development and software development lifecycle.
So where are we now, or what is the status of this silo-like tradition in the processes, and where would you like to be as far as removing that, or these silos go in, say, a year or 2 years from now?
Yeah, so I think the silos exist today, and unless you are a brand new team starting on what we call greenhouse, or really small teams building brand new applications, the reality of the matter is that most software houses, most corporations have large teams, and they're entrenched with what they know, how they work, what tools they use, and this is a difficult problem to solve. People have invested time, labor, effort training and learning some tools or training their teams, and you can't expect them to take it and suddenly throw it away. And then there are political reasons within companies. I manage a team of 400 operations people or 300 testers. You're suddenly asking me to let go of my team. And so this is a hard process, but everybody does realize that you cannot work in silos. And people are starting to look at how to solve this problem. We are, I think, seeing more and more traction because we've been offering this vision and we've been building on this vision of a single application for the entire life cycle. But we also realize that not everybody's going to throw their tools away. So we offer best-in-class repository, Git repository, and CI. But we have a vision that's kind of across the life cycle from requirement management. And so we let customers self-adopt what do they want to move to next and what do they want to move to next. For example, is security scanning of applications you build. It's really tough. And the onus is on the security team. It's usually towards the end of the cycle. And so what happens is you may put in a lot of work and you want to release something. And it's critical it go out tomorrow. But the security team might find vulnerabilities and say, no, go back to drawing board. And now you're set back by, who knows, 3 weeks or 3 months. So how do you integrate this into a single kind of seamless experience and have everybody look at it at the same time and not in sequence? This is, this idea is gaining traction, and we see more and more, companies starting to adopt this. I would say, we are still quite early on in this journey, and I'll see more vendors offering this capability from a single place.
And as far as your engineering teams, you're putting this into practice, and maybe you could discuss some of the metrics that you've achieved.
Absolutely. If you're shipping something to help other customers, it's kind of our culture to kind of dog food our own, offering. And so we have 2 different versions that are 2 different ways to consume what we offer. One is the SaaS, offering, and so you can just sign on with GitLab.com. You don't have to do anything. It's a service, and you can drop your code there. And what we talked about, you're able to take the code from requirements all the way to production and start monitoring with security, scanning, everything built in. Or you can buy the software that, self-hosted version that we offer, and you can host it in your own premise, off some other premise, your choice on how you deploy it, and do the same thing. What's unique about our company is we offer same capabilities, whether it's the SaaS platform or it's the on-premise. And our velocity has to be really fast because it's a very broad vision of what we want to deliver. So we've gone for breadth. So everything from requirements management to repositories to building it to testing it is built into our offering. But we have to keep up. And on our SaaS hosted platform, we do about 165 to 170 deploys a day.
A day.
That's how fast we're building this. And on our self-hosted version, we actually release on the 22nd of every month. We've done this in the past 90 plus months without fail. Because we are an open source, open core model, we have external contributors, more than 2,200. We have our customers, all actually contributing code to make this better. Think about the 100,000 plus organizations who are our customers. They're all working to better each other. So as they contribute code to see something they could add value with or something that they want and we're not getting to yet, they contribute it and we absorb it and we run it through the process. And so we have tremendous velocity. Our last release had 200 plus features from external contributors.
So in achieving this velocity, how long did it take you to do that? And when did you start this process, and what were the biggest challenges you faced?
Right. So I've only been with the company for a year and a half, but reflecting back on what I've learned, this approach was there from the beginning because of the open source model. So much so that some of our major contributors have ended up joining the company. So because of how we are an open core model, everybody can contribute. And what that really means is if there's a feature you really want to see, that our roadmap is open, it's public, it's transparent, you can go and argue there with our product managers. And we might agree to do it this release, or we might agree to do it 2 releases down. But if you really want something that's going to help you or help others, you can contribute and we'll absorb it. And so what we've seen is sometimes our own customers hire GitLab specialists so they can write the code, that's missing for them, and they contribute back to the community. So everybody benefits. Right? So this has always kind of been the model, and it's accelerated. The number of contributors has grown. The number of organizations we serve has grown. So this velocity is, our own engineering team, after a round of funding, we have actually invested in that. So there's a lot of resources kind of focused on making the product much richer, much broader, much deeper. So this velocity has taken off. Our product capabilities almost looks like a hockey stick curve, right, year over year.
So this remains an open source project, obviously, at its core. And at the same time, did I understand you correctly when you said that there are a lot of contributors out there
Yes.
that are being hired by your customers or the GitLab or Git specialists, for example?
Yeah, absolutely. So it's not just our own company that has hired some of the contributors because they've wanted to come work for us, but we're finding that our customers, our partners, they're finding that they want to adopt this, platform, if I would call it that, because it's such an open platform. Not just like how to build it and contribute it, but also what they can influence in which way this is going. Like I talked about, if you go to our website, about.gitlab.com, our product roadmap is right there, and you click in, you can read all the details, you can actually get into the discussion and influence it, which means customers see us more of a partner than a vendor, because they can take the software, they can start using it, and they can shape and mold where this goes to help their unique needs. And so they end up hiring a lot of, GitLab engineers and, GitLab specialists, or just generally people who are really skilled, in software development who can contribute to GitLab. And we see a lot of features coming in, from them themselves or suggestions.
And obviously, are changing the subject, security element remains a huge issue.
Absolutely.
As far as the deployment cycles go.
Right.
And how does DevSecOps play a role? And maybe at the same time, you could give a reality check or what's happening now. And it's my observation that this is very new and it's remains a work in progress.
Absolutely. So the whole idea between DevSecOps is to integrate security much earlier in the process. In fact, if you look at the entire software development cycle and the concepts of DevOps, it is to have the teams work concurrently on the same issues at the same time. Because today it's a very serial, kind of sequential way. The designers are going to design something, right, or create the requirements, they give it to the developers, they do something, then they give it to the testers. Security often comes at the end.
Yeah.
Like we talked about, it can, if they've not been involved from the beginning, they can say this is not going to work and send it back to the drawing board. Because you can't release anything out there in the marketplace that can hurt your reputation, your brand, and ultimately your dollars. So in the model of DevOps, you really want to get the security teams involved much earlier in the process. Even when you're designing and writing the requirement or designing the code. Because now with them on the same page, you can actually define what is it that needs to be designed that'll pass, what security needs to pass. How do you design it? Or you can explain your constraints and they will look at security, kind of policies and work with you. So at the onset, you're designing something and you're rolling it out and you're testing it right at the developer's desktop. So it doesn't escalate into a much bigger problem as it goes down the pipeline. Of course, we know the caveat. We know the saying that something you catch early in development process might cost you $1 to fix. It's going to cost you $100 to fix in production. So everybody's interest lies in kind of designing it together and catching it earlier and releasing it through the pipeline. So this whole idea of DevSecOps is to integrate security, embed it into the process, leave the security teams more focused on the unknowns, the off the charts kind of problems, and only go to them when you don't understand how to solve something in particular. So you arm the developer, you kind of educate them, there's no more, an excuse that I didn't know. Right?
Yeah, I hear this question a lot.
Right.
At the same time, you're, for example, a developer,
Right.
and you're trying to tell your DevOps team manager that, or of course they agree with the concept,
Right.
but what are the practical steps? Even if you're not on the security team, you're a developer. How do you go about implementing that DevSecOps?
So there's always three elements to, anything in DevOps. Let's just take the idea of DevSecOps. There's the people, process, and the technology piece of it. Right? So you need to have people invested in doing the right thing. That's a cultural change. You need to have the right processes and sometimes tweak the processes you have. So we talked about the fact that, you don't leave the security scanning till the end, but you actually bring it right. You bring it to the left, right? You bring it right at the developer's desktop. Now that's easier said than done because tools are still separate. So here's where vendors like us, like GitLab, is designing the application so that the moment you write the code, it's at the developer's desktop. The moment you actually check in the code, you don't have to worry about anything. It's going to check it in, it's going to start integrating it, it's going to start running all the security tests, SAST, DAST, dependency scanning, container scanning. So you need to kind of integrate the tools. If you can't integrate, it is really expensive. Then you look at the new generation of tools like what we are designing that puts that functionality right where it should be, right? And so you don't have to piece together that functionality. So it's a combination of people buying into it, like you said. It's the process. You need to modify your existing processes. But then you need to start looking at, the tooling and the very last that makes this happen.
Actually, one thing, though, it's often overlooked is going to the right. What happens once vulnerabilities are discovered, and how does DevSecOps manage that?
So we have to assume that nothing is ever secure. We can try our best. It's a question of when the security breach will occur, not if. Right? I just talked about zero trust just before this, and so you need to not only check the application for any security deficiencies when you build it, but you have to have policies and enforcements and the right user accesses, etc. Like for example, in our product, when we actually do the scanning for security, known security, defects, and we look at whether the application is secure, and it passes through the pipeline, we actually take the human element out of this. We actually have the pipeline check whether this is a valid and secure piece of software. We have the pipeline actually apply the signature to it, and then actually validate that signature before we release it in production. If any vulnerability is found along this, we will not let it release. Or if it's released, then we pull it back. So it's not just during the process, but even when it's deployed, you have to continuously monitor that. You have to look for both external attacks, but also, like we talk about the traditional security model being really hard on the outside and soft on the inside. That doesn't work anymore. Because once there's a breach, then, people can move laterally. So you have to also have hardened security policies within the organization. Should this system be talking to that system? Should this container be able to talk, laterally to that container? Does the person trying to access, certain data, is it the right person from the right organization with the right view to be able to look at this data or to be able to access this data or manipulate that data? So security doesn't finish just by releasing secure code. It's an ongoing process.
And obviously, as you mentioned, automation is a key aspect for not just for security, but for the whole delivery or the pipeline production process.
Absolutely. I mean, just to take the example in security, when I joined GitLab about 18 months ago, we were about 200 people, 200 employees. We're at 650 today, and we're supposed to be 1,200, by the end of the year. Just even enforcing security policies, you have to automate. There is no way you can do this manually. There's no way to scale this. And when you're talking about large, complex organizations, you just cannot have human beings. And when you look at deploying code, look at the number of tests like, every organization has to run, the number of pipelines that have to be run parallelly, and then, the testing of it, and then the security scanning of it, and then the monitoring of it. You just can't have enough humans. Even if you did, humans are humans, even with good intent. They might have an off day, and, they might have fought with their spouse, might have an angry driver cut them off. And so that judgment always varies on the work that they do. So you have to automate a lot of things, right? And do it in a repeatable manner, scalable manner, and automation is absolutely necessary.
And two questions. How does this apply, though, to the smaller shops or smaller organizations? And what is the threshold when that becomes a factor? And as far as automation goes and this whole process you're describing. But at the same time, I was wondering what, how will that play out in the next, say, year or 2 years from now for cloud native deployments?
Right. So it's a good question I haven't thought about before, but now that you say it, I'm thinking about it. At what size does automation matter?
Yeah.
I think if you're an organization who knows, there's two factors to it. If you're going to scale, the earlier you put in the automation, the easier it is to scale, because you're continuously then tweaking that automation to meet different needs, to scale up, etc. So if you try to do this when you are really big, it's harder. There are people and there are processes doing things, so you want to get this on early. I think the other thing is, even if I am a one-person or two-person shop, I would rather focus my energy and my attention and my time on creating value rather than doing repetitive tasks. So I would advocate for automation as early in the process as you can. It takes out the human factor of error. It takes out the why am I wasting my time on running a script again and again, and why don't I go actually write revenue generating code, for example, right? Or I could even take my dog for a walk. So you free up your time for more valuable things. Sorry, your second part of that question?
Well, yeah, then we kind of didn't touch upon this too much, but how would you describe this context of what you just were talking about for cloud native deployments?
For cloud native deployments. Yeah, so here's the interesting part. When you deploy in the cloud, most people think that the cloud vendors take care of the security, and it's secure. It's in cloud, right? So it's secure. But the matter of fact is that there's only certain components that they secure. So, they're looking at the back end, the infrastructure, the breaches, etc. But we as users or deployers of the cloud native applications still buy third-party vendor products to kind of bolt on the missing parts. But it doesn't end there. We still have to put a lot of processes in place. So it's no good having an enforcement policy, a policy if you don't enforce it regularly or update it regularly. I just talked about the fact that as a company which is really growing rapidly as ours, we have a huge number of people onboarding the company. So how do you make sure whoever is coming in, what role, what organization, what duties do they have, and how do you kind of allocate security policies to them? Then a lot of people always leave a company. They may choose another job. So as soon as somebody offboards or leaves the company, what happens then? Are you making sure their access is turned off? So just because an application is cloud native, your responsibility doesn't end. We cannot assume that the cloud native, the cloud infrastructure provider will take care of all of security for you. There's a lot of work that you have to do as a process, mechanism to make sure that you're in sync with their policies, you've updated your systems, you're making sure whoever is accessing those applications is valid, genuine, has the right access, etc.
Ashish, thank you so much for joining us.
Thank you very much. It's been my pleasure. Thank you for the opportunity.